This lecture will be on unions and intersections and talking about compound inequalities a bit. So, first thing, union is kind of a connection between two things, right? Two sets of information. So, a union is kind of like saying or, right? I could say that one group could have two, or the other group could have two. Even if, like, say, one group was 1, 3, 4, and then the other group was 2, 3, 4. Well, one of the groups has 2, right? So the union would include 2, okay? It includes anything that both of them have, right? So the union would be, like we said, it's an or, okay? Which means that it is equal to the set of, well, if it comes from 1, it's in the union, right? So one of them has a 1, one of them has a 2, at least one of them has a 3, and one of them has a 4. So the union includes all of those values, even though 1 and 2 only show up in one set, not in both, okay? Because it's an or. It has to show up in the first group or the second group to be in the union. Now the intersection is the exact opposite. That's an and, okay? So an and obviously means that it has to be in the first group and in the second group. So 1 is only in the first group, so it's not in the intersection, right? Because 1 is not in this group and in that group. It's just in this one. 2 is also not in the intersection for the same reason. It's only in the second group. So the intersection is only what they have in common. So that would just be 3 and 4, okay? Now, this is kind of the easiest way of looking at it. What if we had inequalities and we needed to look at the number line for it? We still think about it the same way. It's just a little bit more complicated to kind of conceptualize and visualize. So say we had x is greater than or equal to 2 and x is greater than -1. So we should always write out a number line for this. It's the best way of visualizing it. We just need those numbers and then to draw in the correct directions. So x is greater than or equal to 2. That means we have a filled in circle at 2 and then greater than, so to the right. Second one is x is greater than -1, so just an open circle, greater than, so again to the right. So let's first talk about the union. The union of two sets, remember, is what at least one of them has. Right? Doesn't matter if both have it, it's just if one of them has it. It's an or, right? So let's think about values again. Let's think about -1. Does -1 work in one of the sets? Well, it doesn't work in the first one, right? Because -1 is not greater than or equal to 2. But -1 is is not still greater than -1, right? So -1 truly doesn't work in either set. What about 0? Is 0 greater than or equal to 2? No. Is 0 greater than -1? Yes. So that means 0 is in the union because it worked in the first or the second group, right? Remember that or. So because the open circle here, right? We go all the way up to -1, but not including it in the union. So, now let's go further. Is the union stopping at 2 or going past it? Well, we have to decide. It's an or, remember, it has to work in at least one of the groups. So let's plug 2 in, right? Let's see if it works. 2 is greater than or equal to 2. Yes, that works. 2 is greater than -1. That works as well. How about something past 2? How about 5? Is 5 greater than or equal to 2? Yes. Is 5 greater than -1? Yes. So that means we could keep going and picking bigger and bigger numbers, and they'd still be in the set. So that means we go on forever, all the way to positive infinity. The union should always be the bigger of the sets, okay? Kind of the most you can get from them. And this is only kind of a good, how I'm saying it is only good when they overlap like this, okay? We'll look at one where they're different. So now let's think about the intersection. Remember, the intersection is only when it works in both groups. So let's go down and think about 0 again. Does 0 work in both groups? Well, 0 is not greater than 2, so 0 doesn't work. We have to go all the way up to 2 to make it work in both groups. Remember, it's the overlap. It's what they both have, or what they have in common. So, does 2 work in both groups? Well, 2 is greater than or equal to 2, and 2 is greater than -1. So 2 is allowed in the intersection because it works in both inequalities. Now again, it goes all the way forever until infinity. So that means infinity works for both groups, right? Both groups, infinity is greater than or equal to 2 and greater than -1. So that is the intersection. Okay, so remember that union is the or what they kind of from both, right? And then the intersection is the and, it's what they have in common. It's more exclusive, okay? The union is inclusive, the intersection is exclusive, okay? So, now let's think about a different set of inequalities. So say we had x is less than or equal to 2 and x is greater than 1. So very similar, but kind of a little different, enough different to make the unions and intersections very different actually. So we have 1 and 2. X is less than or equal to 2. So we have a filled circle, and less than means to the left. X is greater than 1, so an open circle, greater than, so to the right. So remember, union is everything from both groups. So, well, negative infinity is in one of the groups, all the way up to 2, right? But then this one starts at 1 and up to infinity. There's no number that we can choose that doesn't work in at least one of the groups because they go in opposite directions and they overlap. So that means that this union is all real numbers, okay? Then the intersection here is, remember, it's what they have in common, what works in both of them. So 1 doesn't work in both groups, right? Because 1 is not greater than 1, but 1 is less than or equal to 2, but it's kind of where they start overlapping. But because 1 only works in one of the groups, it's not a bracket, it's just a parenthesis. So that means we start at 1 with a parenthesis. Where do they go to overlapping? Well, to 2. They both can be 2 though, right? Because 2 is less than or equal to 2, and 2 is greater than 1. So that means 2 gets a bracket. So these are kind of 2 different options for number lines using inequalities to write unions and intersections. Remember the ors and the ands. They will help you kind of say that in your head as you're thinking about unions and intersections. Now, I did promise to talk about compound inequalities with this as well. Compound inequalities are a little different in that first we have to solve them out, and then they will mention and or in the middle of them when we're solving it. So, if they tell us and in the middle, well, that means realistically it's the intersection. So once you if you have your first inequality and your second inequality and an and in the middle. solve them out until you get something with x and something with x, right? Just like we did on the last two problems, draw out the number line. Then see where they overlap, right? What they have in common, because we're looking at an and. Okay, that will give you the intersection. Now, if instead it had an or, we do it the exact same way, except once we get to the number line, we just look and see what is there, right? If they overlap at all, well, cool, that's fine. Do they go in the same direction or in opposite directions, right? So that's how we want to write out that interval, or possibly the finished inequalities, okay? You can always go back and check, pick a number in your interval that you have at the end, check it in either one of, right? It has to work, or if it's an and, check it in both inequalities, your original inequalities, and that should show you if it works or not. Now, there's one other type of compound inequality that you can get. It's one that has three sides. So say we had 1 is less than or equal to 3x plus 4 is less than or equal to 7. I actually don't know if this works or not. I hope it does, since I just made it up. But this, when it's given as one set piece, right, just three sides, it's an and. This always has to be an and, because the middle is both greater than or equal to 1 and less than or equal to 7. Okay, so it's kind of mixed into how you say it even. Now, Alex will show you breaking this into two pieces. You can do that if that makes sense to you, or you can solve this as one piece. I'm going to show that just so that you can see it done. So whatever you do to one side, you have to do to all three sides now, because it's a three-sided equation, essentially. So first, right, think you're solving for x. So that means subtract 4 from all three sides. So 1 minus 4 is -3, still less than or equal, because remember we only change inequalities when it's being divided or multiplied by a negative number, not added or subtracted. The middle is 3x, still less than or equal to 7 minus 4 is 3. Oh, that worked out really nicely, actually. Now we divide by 3 everywhere, and it's a whole bunch of 3's, so we get a -1 is less than or equal to x is less than or equal to 1. Again, draw this out on the number line. The really easy way of drawing this out, and why it's nice to keep it as one piece like this, is because it's set up like this, -1 is less than or equal to x is less than or equal to 1, meaning -1 is less than or equal to 1, which is totally true, right? We draw -1 and 1. They're less than or equal to's, so they're filled in circles. And then the x is in the middle. So the section is in the middle. There we go. There's our number line. Now, our interval notation would just be bracket -1 to 1 bracket, because they're filled in circles, and it's just that little piece right there. And that's an and, because it's both greater than or equal to -1 and less than or equal to 1. Okay, that's compound inequalities and unions and intersections.